Hello, hello, hello. Hello, world. If you're on LinkedIn, happy Wednesday. We are extremely excited to be sharing the making of BIMIT plan live with some of the makers themselves. We'll give folks a few minutes to start joining in. Across the next 45 minutes to 60 minutes, we're going to be sharing the story as to one, how we've digitized 6,000 buildings manually, what that's meant in terms of the importance of standardization, how we've learned from that information, and then how we're thinking about commercializing the service to provide the service to the industry. So you're joined by an incredible group of folks here on the call. I'll pass the baton maybe to see. Also, we're joined backstage by Sean, who's helping us on the back end. He's, while we can't see who's joining, he's going to be sending us messages to just kind of keep track. Should you have any questions to the panelists, encourage you to drop it within the comments in the LinkedIn page. But yeah, incredibly excited to spend the next 45 minutes to an hour here just chatting about how the heck have we automated scan to plan. So with that, I'll introduce myself briefly, pass the baton on to Preston. But I'm Jose, the founder of Integrated Projects. My personal background is worked as an architect, found myself designing a bunch of spaces, only to realize that the background existing conditions drawings were inaccurate. I ran into that problem once, twice, many times over, first as a designer, then as a construction manager. So it started what's now become a decades-long obsession with how can we get better documentation of existing buildings. Turns out the technology is nothing new. Scan and BIM has been around for some time, but the way that we streamline these services and scale these services is something that has certainly kept me up for the greater part now of a decade. So I'm really excited what that has materialized into today, and we'll dive in deeper. With that, I'll pass it on to Preston.
Thanks. I am Preston Smith. I lead automation here. I've worked with integrated projects for a couple of years, but my background is in architecture, similar to Jose and a lot of other folks on the team. I've worked as a designer for a few years. I love design. I have nothing but incredible things to say about the architecture community. And I found myself kind of really wanting to work more on the technical aspect of design as I started to continue to work. So spent a few years as a BIM manager and then quite a few years as a software developer before meeting Jose and joining Integrated Projects. My job here really is to kind of help automate what BIMOps creates. And Debbie's done a great job of standardizing everything that we do right now. And I work with Thomas and a few other extremely smart folks to make sure that we can automate scan to BIM. I'll pass it on to Debbie for now.
Thanks, Preston. Super excited to be joining today. I'm Debbie. I'm leading BIM operations here at Integrated Project. I'm an architect and BIM specialist. And right now, basically what we are doing, besides working on the standards that are the foundation for automation, we're going to talk about this later. I'm also overseeing all the projects that we are delivering. I will pass the baton to Thomas.
Hi, everyone. Thomas Czerniawski. I've been working in the construction, architecture, engineering, construction industry for a long time now. Used to work out on sites, but went back to school, became an academic, learned how to code and learned about neural nets. First learned about integrated projects about 3 years ago. Started to have conversations with Jose about what would actually be required in order to approach scan to BIM automation. It was but a dream only a few years ago, and super excited to be releasing what we've been working on. Happy to have the conversation.
Yeah. For those listening in, we deeply appreciate your time. We acknowledge that there's a million things you could be doing on a Wednesday. For those on the East Coast during your lunchtime, those in other parts of the globe, either in your morning or evening time, we deeply appreciate your time. We trust this will be a substantive conversation and a bit of a storytelling. one thing that we acknowledge as a team is that in the age of AI and automation, I think that there's certainly no shortage of smoke and mirrors hype. Uh, we've been talking about digital twins now for the greater part of over a decade and a half, certainly since I've been in school for sure. So the topics we're talking about today are not new. We've been promised the world, and we're very much acknowledging that I think what we're suggesting here, if true, is big, but also we have quite a bit to work through. Scan to BIM and scan to plan is something that we think in and of itself should exist to better document buildings. The problem we found is not that there's a lack of digital twins or good ideas or even BIM. I think the bottleneck that we found that has not enabled us to digitize buildings at scale has actually been production. There's no shortage of dashboards, software, design authoring tools to create CAD and BIM. But what there is an inability to do is to effectively, affordably, in a standardized way, actually turn physical assets into accurate, verified digital versions of it. Today, it's costly. It requires a ton of technical expertise. You might see it on billion-dollar trophy projects, right? A true 3D model of a tower, for example. But the real question is, how do we digitize entire cities, neighborhoods, states, countries, so that we can be proactive about the spaces that we inhabit, how we can proactively improve them? We believe that bottleneck is actually just production. It's unsexy, very much considered kind of in the realm of scan to BIM and surveying, and we love that kind of messy middle. And so today's conversation, I think, is embracing the messy middle. It's like what it's taken us to get here. To set the stage, so after 6,000 plus buildings that we have manually modeled, down to every conduit, element, door, column, window, floor, we've now reached a certain threshold that has enabled us to launch BIMIT Plan as of yesterday. It's our first fully automated scan to plan service that enables someone to ingest a point cloud and get an automated floor plan in the form of PDFs and DXFs out. We think that this is a super meaningful first step, first milestone, in what promises to be kind of a series of milestones to get faster, more affordable, more standardized outputs. We think this is a big deal for owners, for architects, for builders, for laser scanning professionals, those that are actively acquiring or renovating spaces. The faster, the more affordably you can get this information in your hands, the more we're going to be able to renovate at scale in a more proactive way. So with that, the folks that are joining me today are reflective of an incredible team that you're not seeing here. These are folks that are on the front lines of quite literally seeing the production of hundreds of building models every month. Debbie is overseeing the production and quality control of every single model that we produce. Thomas has taken thousands and thousands and thousands of data points, from point clouds to models to segmented point clouds. And we've had to make sense of all this messy information. And Preston has been essentially the reason why we've put this all together, commercializing what has been historically really a research project. And how do we put this out into the wild to learn and to create real value? So you're talking to folks that I'm incredibly grateful to be working with, and excited to really to share their stories. But with that, I want to hear from Debbie. Debbie, for those listening in, again, you're on the front lines of seeing hundreds and hundreds and hundreds of models being produced. This is stuff that, architecture and engineering firms have been trying to do forever. Standardize one project to the next. Like that in of itself is hard. How do you go from one project to 100 projects with a global team all around the world? Like, where do you even begin?
That's the question, right? Before we talk about automation, which I know many of you are here for, I want to take a step back, because here at Integrated Projects, automation didn't start with like only machine learning, but with standards, and those standards started as a response to a very real operational challenge. So let me give you a little bit of context. When I joined the company about 2 years ago, we were growing super fast. Demand was increasing, and our operational structure wasn't ready for that level of scale. So today, as you mentioned, we are overseeing close to 100 projects per month, some months even more, which is huge. We have a strong product vision, and also, as you mentioned, we have a global partner network of BIM specialists working across different countries and different time zones. But then the system wasn't, I think, mature enough to support that volume consistently. So, for example, on-time delivery, which is still one of our top priorities today, started to slip. Teams were overloaded, and basically what happened is that production wasn't standardized enough. So at that time, we had defined the product, meaning the what, but we hadn't fully defined the how. And when you want to operate at scale, the how becomes basically everything. And what was happening is that, for example, two different teams could model the same wall in completely different ways, and both believed that they were correct. That was the funny part, because we were only defining the what and not the how. It left too much room for assumptions or gray areas. And that was when we understood that the problem wasn't skill, it was clarity, it was standards, and some other things that I'm going to talk today. So we realized that the challenge was organizational, something related to what you're mentioning. Our question was, okay, how do you create a worldwide network of BIM specialists that all produce the same quality, the same logic, and the same consistency, and adding another layer of complexity that is working fully remote? That was, and honestly still is, one of our main challenges. And I might say that the biggest lesson learned in this is that in a global remote environment, you can't assume alignment. You have to design that alignment, that it's super important. So what we did, well, basically we rebuilt the BIM operations from scratch around two main pillars. First, leadership, and then standardization. I'm going to talk very briefly about the first one, leadership. What we did, we redefined the role of our project leads. So instead of being just reviewers, they were like, we set them to be mentors and coaches. We created strong feedback loops, clear ownership, clear communication, which is absolutely key, and also clear expectations. So what we wanted is our partners, our BIMIT network, to feel part of the company, to share the values, to share the vision, and not just be external production capacity. The result, well, over time, teams that maybe they start super small, they grew 2 or even 3 times their in size. Then also on-time delivery was recovered. Today is better than ever. And most importantly, production became predictable. And I think that predictability is what makes learning possible. So now talking about the other pillar, standards, I might say that the real turning point came when we decided to formalize our standards at a much, much deeper level. So once we have the right BIM operations team in place, architects and BIM specialists with strong experience, super happy to work with the team. What we did was to start doing weekly standardization work sessions. In fact, it's something that we still do today. And we broke down the entire model by building elements, walls, floors, everything. So we didn't just describe them, which is basically what we had before. We defined how they behave, how they connect, how they host to other elements, how they should be edited or modified, and how they relate to the rest of the model. So instead of having these kind of guidelines, we start having rules. And instead of having descriptions, we start building a system. And as you all might know, once you have the rules, you have the logic, and this is where the narrative maybe connects, because we often say this internally, that this works like a loop in which automation is not possible without learning. Then learning is not possible without consistency. And of course, consistency is not possible without standards. And then it starts over again, in which, because basically those standards need to be continuously refined and improved. And yeah, I think that by standardizing production across our global partner network, we created this structured and reliable data. That is this data is what enables machine learning. So that was a little bit of history and context, and I would like to close this first part with a reflection, because I think that BIMIT plan, what we are presenting today, is it's not just an automation milestone, because I think it's the result of, I might say, years at this point of operational discipline, cultural alignment, and of course, technical standardization. And yeah, and what makes me proud today is not just the product. So I think that the foundation that we built is what allows us to innovate with confidence, which is our real value. So yeah, with that, I will pass it over to, I think, Thomas.
Thomas, before you get into it, I wanted to maybe tell those listening a quick story. I will never forget. I met Thomas on Twitter, on X, right? And I think for some time, we were putting out content about just the work we were doing. Somehow, I don't remember the details, but somehow Thomas made his way to New York, and somehow we met at some restaurant. I'll never forget. Thomas was like suited up. I was like, oh man, this guy's serious. And we had a conversation about, the state of the industry, scan to BIM data, what needs to be true. I mean, this is a guy who spent years like studying this stuff. And over the course of the dinner, we were just discussing about like what needs to be true in order for us to actually achieve this. I think everyone's been talking about it for sure, but like what's been kind of the missing link here? Fast forward to today, I guess what, 2.5 years later, something like that. We're now commercializing what at 2.5 years over dinner, we were just talking about like, hey, wouldn't it be cool if we did this? I mean, Thomas, take us all the way back. Like, you were an academic, you were studying this stuff, you ran a lab on this kind of stuff. What was unique in that? Like, what convinced you to go from academia, leaving like a pretty comfortable job, to joining a small startup here with big ambitions?
Yeah. I mean, it's been a long journey. I first started on this problem during my master's, when I was creating a pipeline just for recognizing pipe spools and point clouds. And that's a much simpler problem than the one that we're facing today. You look for something that looks like a cylinder, you isolate it, you analyze it to see if this pipe spool has been fabricated correctly. Then for my PhD, that problem was scaled up from a single type of element to maybe a dozen elements. And that was a recognition problem in range camera data. So with an iPad, I would go out, I would scan some areas of buildings, and the neural nets would recognize one of a dozen categories of building elements. It didn't perform very well. It failed more than 50% of the time, but it kind of gave me a vision of how this process could look like. You get some neural nets, you string them in a row, they each do different tasks, but it kind of hinted at the possibility of scale, because of course, scan to BIM doesn't just require the recognition of one type of element or even a dozen types of elements. In a fully fledged scan to BIM system, you could be recognizing hundreds of different types of elements. And that's something that really couldn't be achieved using more traditional computer vision algorithms. And so after the PhD, I was in Arizona running a lab focused on not just scan to BIM automation, but just kind of digital technologies in general. But I always had that kind of thought in my mind that, like, I kind of see that there is a opportunity here, and we needed to find a way to exploit it. And for me, the kind of the missing link that was kind of preventing me from going all in on the problem was just an access to data problem, where, I had laser scanners in my lab. I had, many students volunteering to collect data for me, but there's only so much that I could collect even with an army of students. And so I thought that a scan to BIM service provider could be that kind of data gold mine. And so, looking at, many of the service providers on the market, I saw your BIMIT calculator, and just like the quality of the design on the front end. And it seemed like you guys were very thoughtful about the way you were approaching standardization, as Debbie has covered. And that's a really important part of a training data set, because you can have an enormous data set, but without standards, it's almost impossible to exploit for machine learning. And so I saw that calculator, I saw how rigorous the standardization was. And so I started to follow you guys on Discord when that was still active, and on Twitter, reaching out to you and thinking maybe we can partner in some way. And over the course of several months, we came to an agreement that we should just go all in on this and try to, like, really give it a go. Something that everyone in the industry has been talking about for years. And this was like the first hint that we might be able to get something with commercial viability. That was 2.5 years ago. And I admit I was maybe a little naive about how difficult the task was going to be. This really is something that is on par with self-driving, I would say. And we all see the self-driving companies and just like how long their journeys have been. And like, okay, we're going to get this thing to drive on a highway without intervention. And then, well, now you're going into dense urban environments and you're going global, and you're dealing with all these edge cases. And it seems like self-driving is kind of getting to the point where it is almost solved, but it's been a long road for them. And I suspect, as hard as it is to admit, we all want quick kind of results, but we're likely going to be on a very similar trajectory with scan to BIM, where we have something. It's, everyone can go to the scan to plan website, throw in a point cloud, test it out, see where we are today. But what we're releasing today is very much the beginning. We have internally outlined kind of these 4 strategy paradigms. I don't want to go into too much detail into them because it is trade secret. And I know there are people out there that are looking to compete with us on this. But of these 4 paradigms, we've maybe progressed through 1.5 of these strategies. And the reason we haven't progressed all the way to the 4th strategy is because the 4th strategy requires a lot more compute than we have today and a lot more data than we have today, even though we have probably the largest data set in the world at this point. Tesla has 6 million vehicles on the roads collecting data for their self-driving teams. That is a scale of data that is beyond BIM at this point. No company, I don't think we can even aggregate as much data as Tesla has. But we have to get there slowly. We'll be rolling out automations. We'll be growing the size of the BIMIT service. The size of our training data set is going to grow as a result, and we'll progress through paradigm 2, then 3, then 4, as our access to data and compute increases. Right now, we rely a lot on heuristics and human expertise, engineers and architects sitting down and very carefully drafting rules on how we can clean up the point cloud data, how we can clean up the results of the neural networks that are still within this first and second paradigm. And there's only so much that human expertise can clean out of a messy point cloud. If the registration is poor, if the colors are poor, if there's a lot of glazing and there's noise all over the place, there's only so much that we can encode in rules. And these are problems that you can only really overcome training really massive neural nets. But that'll come in paradigm 3 and 4.
Amidst that messiness, Preston, you and the team and the automation team have been tasked with, in a sea of opportunity and challenges and things like that, to really kind of laser focus on how can we drive value to folks today, albeit, however modestly. How's that been? Like, how do we connect all this crude data, messiness of this data, and make sense of it in meaningful ways for some folks?
I think part of it is, we've already addressed it a little bit. Part of it comes down to what Debbie mentioned, which comes down to standardization. So looking at the problems we've seen, abstracting that a little bit more to understand how common some of those problems are, and then solving for the things that we think are the most important. The second part comes down to what Thomas mentioned at the end of what he said as well. Humans are really, really good problem solvers. They're actually also impressive problem definers. And so I think the better skill of the collective team has been problem definition, not problem solving. While it's true humans probably aren't going to be able to scale as fast as machines, they kind of don't need to. A lot of what we've achieved so far has been the mixture of understanding what it is that we're actually trying to solve for, and then applying a solution like very, very quickly there, right? It's like the idea of a simple tool, like a hinge, right? Or a lever. So we don't need to solve everything at once. In order to ship, we can solve just small problems, get more information, and continue to build feedback loops to continue to solve as we go. And right now, I think it's going really well. I think one of the biggest advantages that we have over other folks that are trying to solve this problem is the expertise of the team. Some of the folks on our team have actually worked like in the field, building things with their hands and with other folks. I remember sitting in a conversation with Debbie and one of our colleagues, Neen, he was like, nope, that's not how you would build that. And it was, so many of these discussions are what it comes down to, because trying to figure out whether something's a window or a curtain wall at this point still needs a human, and actually probably needs more than one human sometimes. So it's an interesting fact, because as Thomas mentioned, this is, I think if Elise said something similar when she was talking about this, but the self-driving industry has had 20 years or something of this kind of data. And I think we've got something similar, but not focused on this problem the same way. So that'll be our edge, I think, is that we're finding very quickly where we don't need to be involved, and we're shifting that over to a computer, and then finding new ways to prove out or push our human ingenuity to the right side of the problem.
Right. I do want to continue on this. I want to show kind of a multi-part question here from Preetham. So Preetham, appreciate the kind of multi-part question here. A lot that's baked into here. Maybe starts with the first one. In your experience, what are the top organizational barriers to integrating AI automation into AEC delivery workflows, especially where teams are already stretched during high peak loads? This is a loaded question here, and I think a multi-part question. I think one thing, one perspective is, in the age of AI, I think a very important shift that we're seeing generally, not just us, but just in general in the market, is that you're seeing the cost of software being driven to near zero. These days now, a lot of folks could build their own software. AI is also showing us that we're moving from it building tools to actually building services that are just done for you. And I think that this is a very important distinction. This was not necessarily true just 2, 3, 4 years ago. we saw like a rise in tooling. But what we're suggesting here, at least we are, is that there's actually nothing here to learn. Like this is, I think that the technology that we are making available through human intelligence has effectively meant that we can take a laser scan and output verified, accurate, precise models done for you. I think this is an important part because this is an important evolution that I suspect is going to continue in AEC. I think AEC in particular has a certain level of threshold and expectation on accuracy, precision that I think in other industries, you know, may be fast and loose with it. So hence why you've seen us take quite a bit of time just to get here. As excited as we are about automated floor plans, we're certainly not pretending that we're precise or accurate as humans today. We can see kind of a roadmap as to how this continues to get better. But this is why I think this kind of technology has taken some time. Like when things go wrong in construction, there's real consequence, and that's something that we take really heavily.
Can I jump in on that one really quickly too? Because like I think this is a really important factor. Is the trust part, and I think almost all of us that have worked in this space have had some, like, for lack of a better term, like snake oil salesman try and give us some vaporware that just wasn't going to work, and that's just the default attitude towards technology as a whole. And I remember being a software engineer inside of an architecture firm, and it's just like this sort of like not understanding of how we do things. There's a over bias sometimes on the way that you do things in a manual way, which is great because we should, and I learned how to draft manually and so on. But there's a way to take that and kind of build on it, right? Like take the wheel, build a car, like learn from the things that we do. But we do want to consider the fact that like biasing trust is there for a reason, because as you mentioned, the consequences are much greater. Going back to the example of self-driving cars, I remember reading about a car kind of being on the road and it couldn't tell the difference between a human walking and a bike because maybe it just didn't have enough of that data, and it kept starting and stopping until it actually hit the person on the bike because it didn't understand pedestrian versus vehicle. And yes, it was just such a strange thing. And so imagine those consequences in the spaces where you live or in other cases. The consequences are just that crazy. So it's good to bias trust, like only speak to the things that we actually can do, which we have spent a lot of time doing internally, externally, etc. Just because the consequences are so great, and we want to take that seriously.
1,000%. 1,000%. Debbie, I'm curious if you have any thoughts on this, or perhaps kind of the second part of Preetham's question, which had to do about change management. Like you talked about standards, you talked about like very practical ways that we can set the guardrails, set the rules for how we can design a product. Anything that you found is effective when communicating across big teams, global teams, doing multiple projects with tight deadlines? Like what's been some practical things that have worked?
First, I would like to add a note on what we were discussing a few minutes ago, is that I think that something that we've been learned is that automation cannot be introduced as a parallel like experiment during peak load. I think, and also based on our experience, that it has to be integrated into the operational system. I would like to start with that. I think it's super important, super key. And then regarding change management, I think that the biggest mistake that companies make is positioning AI as a replacement. I know that this sounds like super cliche, but it's something that happens instead of being an enable. So the moment people feel threatened, I think that's where adoption slows down. So I think that the first step is narrative. Like AI is there to remove like friction, not to replace expertise. And then second, but not less important, I think that you need to identify like the real skills gap, because in AEC the gap is rarely technical coding skills. It's more it's usually system thinking. So I think that we had the most success by upskilling people in three areas. First, understanding standards deeply, super insisting with standards, but I think that they are the foundation to what we are doing right now. Second, understanding data structure. And third, understanding process logic. So once people understand how their modeling decisions affect downstream automation, they start working differently. That's what we learned. So yeah, and another key element is, and this is super important as well, is to involve delivery teams very early. Not introducing AI as something built by tech, but as something that co-develop with operations. So something related with what I was saying before. So yeah, I think that to wrap up, adoption increases a lot when teams feel the ownership.
Can you say more about that one, Debbie? Because I think that's the key part. Is like one of the key parts you said was AI as an enabler. Like we are trying
Yeah,
to unblock you, not replace you. And I know that we talked a lot about that before, but I think it'd be worth
a
it saying.
lot.
Yeah.
Well, working with such like a number of different teams across the globe, something that we learn is that yes, sometimes it's difficult to tell like these teams to say, hey, right now we have a new AI tool and we need you to implement it. So um, I think that's not the way that we should be building things or tools. We need to involve these teams that are part of our current workflows to be part of the designing of those tools. And that's where, as I just said, they are going to feel this ownership and be more prepared for using them. But yes, involving teams early, I think it's key in
Deb,
terms of change management and AI adoption within the industry.
Debbie,
And
what would oh, this is clearly a exciting conversation here.
Hot
Debbie,
topic.
what would you say? So for those listening, what would you say? Someone that tells you, but Debbie, like, listen, I'm a BIM manager. Like, of course, standards are important. Like, I'm struggling to get folks on the same page, like from one project to the next. Like, let alone like doing anything at scale. Um, One of the things that stands out to me that I think was the turning point, an inflection point for us was kind of being clear about what we actually didn't include as part of the product. Can you speak more about like how you managed to work through that? Because the reality is that in SCAN-BIM, I think one of the challenges is that you can become infinitely complex. I mean, a building is really complex. You can, depending on who you talk to, levels of detail or preferences are different. How do you navigate all of these different variables?
The answer is standards. And I think that within Scan to BIM specifically, it's super important to scope what you're doing because, as you said, it can be infinite. So being very clear within the LOD, what are we including? Because we can have very robust standards, but if we don't have defined what are we including, what are not including, we are the same. It's the same as nothing. So that it's like stating what we are doing and what our product is including, it's key and fundamental. That's why when we start breaking down the building elements, in order to do that, we needed first to have a building element list to say, okay, if we're going to deliver our BIM model, which is our product, this is what is going to be included. And once we have that list, okay, let's work on this list. So we are starting from the macro to the micro. But yes, that was basically scoping and understanding that the limitations are the ones that are giving you the flexibility. I know that it sounds rare, but it's like that.
there was actually something else within Preetham's questions. Oh, that's really nice of the person to say. That was more about like the organizational barriers. I think, and Debbie, you mentioned this earlier as well, but I think one of the things that is most important, and we kind of talked about this already, is you actually don't know what the problems are. And I think sometimes we come in with a kind of idea of what the problems might be to help someone actually integrate. You have to ask. That's just it. Like there's still machines can do a lot of things. They can't talk to people.
100%.
So
Yeah, I can't agree more.
right. So, I mean, a lot of what we did when we first started, especially when we were having problems with on-time delivery, a lot of what we did was just talk to people. We sat down, we asked them what was going on. Why is this a problem? Why is that a problem? We like drew diagrams based on things that were actually happening. And then by actually looking at what the problem was and what people were saying and what they were saying was the biggest problems for them, we designed solutions for those. Most of the automations that we've created so far had to do more with process and making sure that people can get information. And if you can do that, then you build trust, which then builds this feedback loop of, okay, I am willing to continue to work with you, and you'll get more and more and more and more insights. So you only get the opportunity to standardize by actually talking to people. Humans cannot be automated out of this, and the more that you
Yeah.
do, the more that you're going to find that things are actually going to be bad. So just talking to your humans is the
You know, Preston, that I always say that you can have the better standards, the most robust standards, but if you don't have the teams, if you don't have these relationships built upon trust, you don't have anything. So yeah.
If I may jump in. So this point of trust, we've been having a lot of conversations with customers over the last few days with the release. And the concept of trust comes up over and over and over again for I think all of the right reasons. Because automation is imperfect. You look at a result, sometimes you don't really know what is right, what is wrong. And I think that process of evaluating an automated output is something that we need to work on. I hope that everyone that's listening will reach out to us and help us to develop that infrastructure for evaluating automated outputs. Like, really, what we need is something that you can look at and it becomes immediately apparent where the automated system made mistakes, because through that kind of feedback and that kind of understanding development, that is really how trust is developed. And we see like two avenues for developing this trust. One is coming up with a standard benchmark. It's something that we've been wanting to fully flesh out for a while now, and slowly we chip away at it, kind of in parallel with actually developing the system. But internally, we've put together these data sets. We call them like comprehensive 100, comprehensive 20, office 20, residential 20. And through conversations with customers and learning like what is actually really important to you of being qualities of these automated outputs, we incorporate those into the benchmark data sets. And when we release a system like this, like all of the frontier labs, we want to just run the benchmark through the system and provide a detailed report of, this is what we did well, this is what we didn't do well, with rich visuals, and that's really what we want to get to, so that we can provide that, so you can study it and be like, okay, I see that this is how like what the system's performance looks like today, so that when it's crunch time, you're on a deadline, you want to hammer out some documents, you know where it can be trusted and where it can't be trusted. And that benchmarking system is still something that's in development, and we hope to release it for you all soon. In addition to the benchmarking system, we also want just infrastructure for visualizing all of these different things from different perspectives, overlaying the model and the CAD and the point cloud and isolating slices and elevation views and all of the typical things you would do when flying through a model to evaluate quality. We want to make that as easy as possible. We've already done quite a lot of work on the front end to kind of give you a sense of what the process looks like. Okay, this is your input point cloud. This is how it's being segmented. This is what the model looks like. This is what the CAD file looks like. But that doesn't give you the whole picture. We need to somehow integrate all of these different data modes into a single interface that allows you to fly through, or even us kind of presetting some kind of a fly through, just to make that evaluation of the model as just like easy as possible. We really don't want to hide anything. We want to make it as clear as possible like where the system is, where it can be trusted, where it can't be trusted, to make it also as easy as possible for you guys to give us feedback, so that when you see something in the benchmarks, or if you see something in this overlay interface that you think is a critical limitation, you can surface it, with links and paragraph references to be like, hey guys, like if you solved this, it would greatly improve the value that I see. um there's a lot to do, but that's kind of where I see the next few months taking us.
So let's get specific here. I'll toss this one over to Preston, but anyone open a chat here. Okay, so we've announced BIMIT plan. Users can now upload a point cloud up to 20 gigabytes into this engine. What the heck does that mean? What's happening under the hood? What's true today? What's not true today? What can folks expect?
Yeah. So right now, as you mentioned, anyone can go on, find BIMIT plan. You can Google it. We've done pretty good SEO work, so you should be able to find us. We'll also include the link in the chat. Go to BIMIT plan, upload a point cloud. We can take anywhere up to, I believe the limit is now 30 gigs. And we're offering actually double the square footage. So we typically will offer free square footage, 50,000 square feet for you to process, for us to look at, and for you to see the results. And you can run it through our system. And what you can expect is really, really, really impressive, we think anyway, interior architecture. We've also included some furniture. So most of what you need to understand the envelope of a building, if you're trying to understand gross square footage because you're working on the real estate side of things, or you're an architect trying to understand your space and figure out, is this ceiling in the right spot? These are things that you can do currently. Everything is not perfect. We like to talk about ChatGPT v1.0. Think of it a lot like that. But remember how impressive ChatGPT 3.0 was, and then how quickly everybody else kind of caught up. That's kind of where we're going right now. So our goal right now is to show you what we already can do, and very, very quickly where we're going is going to be much, much better. So the initial results, I think, are already extraordinary. We've been working on this for months, but really just super, super focused over the past 6 weeks. But we'll expect to see a lot more soon.
Talk to us about time, like cost, time, like what.
Yeah. So, I mean, right now, we've talked a little bit about time. You can get something back in under an hour. Now, this is one of the things that we've talked about quite a bit already. Is this is the worst it's ever going to be. This is the slowest it's ever going to be. This is the most probably costly it's ever going to be. And right now, the cost is free. So you guys should be able to get quite a lot in the near term. In fact, I would take advantage now because it's free. So come take advantage. But shortly we're going to release costs so that you guys can better understand where we're going. But we're going to be on par with a lot of the other laser scanning vendors. So if you've used any of the schematic plan or other kinds of plan services that you've seen out there from various other laser scanning pros, expect to be around there in terms of pricing and everything else. The speed is enormous. We are, at the last time that I checked, anywhere from 20 to 80 times faster than manual modeling. So worst case scenario, you try it out, you get a bunch of walls, floors, windows, doors, everything that you would need to kind of start out with something. And our accuracy, as in what our LOA has been on our test database, has been close to 60%. Some of the work that Thomas and our other colleague Wayline have done have pushed that up 10 points since the last time we checked. And we haven't even checked on this last version yet, so we're expecting even better. Recall hasn't been checked quite yet, but we're expecting some numbers on that soon. So the point is that you'll be able to get quite a lot. And this goes even before we start to talk about the human intelligence that has been packed in at the end, which I'm starting to label in my own head architectural intelligence, because we know what a plan looks like. We know what it should look like. So anything that was missing that's kind of obvious when you look at a plan, you're like, doesn't quite look right. We'd probably solve for that pretty soon. But if you're seeing things that you wouldn't expect, reach out. That's the point. We kind of want to talk to folks, figure out what these edge cases are, work out the kinks, make it so that this is something that's providing value to folks as soon as possible. One last thing though, and this Thomas brought up some really important points. We're talking about the kind of the roadmap. Is one of the things that we started to look at when we first were thinking about this latest release was this idea of believability. There's something to this. Like when you look at a plan, it could be right, but it doesn't look right. Like you can't quite like grok what's going on. And I think that is something that we're using right now, but we will be building up other tools so that people can use not just this idea of qualitative understanding of what looks right, but quantitative understanding of what looks right. We're giving you guys the tools to do both as we continue. But it's something that's been key in our mind as we keep working through this because, yeah, I mean, for all intents and purposes, you're meant to be the judge as the user and consumer. We want to kind of work with you guys to make sure that that's true. So I don't know, Thomas, if you want to say anything else about that, because I know we talked quite a bit about it.
Yeah, just maybe some guidelines on point cloud submission. So the system currently doesn't perform equally well, regardless of what kind of point cloud, what kind of facility you submit. There are definitely best practices that can be followed. Currently, the system performs best for residential and for office type spaces. We can, of course, also process other types of spaces, but at least in my experience, if you want to get as good a result as you possibly can, I would kind of stick to residential and office. We for sure can't do kind of like infrastructure, like you're not going to submit a point cloud of a bridge and get a good result. In terms of formatting, we do prefer colored point clouds. We don't do black and white. The z-axis has to be pointing upwards. It has to be gravity aligned. If your z-axis is off, the pipeline will just not perform very well. If you want to go in and do some cleaning to kind of help the system out, we currently run a process that trims away pretty much all of the exterior space. If you want to go ahead and do that preemptively for us, that helps us out a lot, because occasionally the automated system does make mistakes, and that introduces all kinds of noise into the process downstream. And then if you want to help it out even more, anything that causes noise like mirrors and reflections and glazing and all of that kind of stuff just introduces noise that causes, like ghosting in the walls and misplacement of windows. And like if you really want to push the system as far as it can go, going in and clearing out as much of that noise as you can, of course, like it's super tedious. We're working on reliability in the face of noise, but that would be helpful. And then of course the quality of the registration is really important. If the point cloud has registration issues where walls have duplicate planes, this affects the quality of the output. Unfortunately, we haven't yet overcome and kind of become resilient to registration errors. We do intend to become more and more resilient to that thing over time. But right now, if there's kind of misalignments in the walls, that shows up in the resulting model. And so you have to do a really good job of making sure that the quality of the registration is high. And then finally, point cloud coverage. Right now, the system does fall victim to poor coverage, where maybe you kind of stick the scanner into a room very briefly. Maybe the space is really cluttered, and because you only stuck it in briefly, there are many occlusions. This also affects the quality of the model that is produced. So maximizing coverage, reducing the amount of noise, trimming the exterior, making sure that Z is up, making sure that there is color, and focusing submissions on office spaces and residential. This will really kind of push the system to perform as well as it possibly can today. Deviating from that, and I mean I guess there is no warranty yet. Eventually there will be, but deviating from that and say the quality of the output won't be as good as it could be.
But all that being said, send weird stuff. We want to see.
Yeah, we out of morbid curiosity, send us all kinds of crazy stuff. And the quality of the model will be low, but at least for us, we'll better understand the failure modes of the system, which is equally valuable, if maybe not as pleasant to look at on your end.
But continue to do it. I mean, even some of the things that we've seen already, some of the curved walls, some of the curtain walls, right? Like these are things that have drastically improved with this release for a number of reasons, and we should expect that folks will be able to see improvements in future releases. So try it out now, and then try it out again in a couple of weeks, and a couple of weeks after that. It'll just keep getting better.
Exactly. And guys, on that point, I do want to address for those watching, there's a QR code here at the top left. For those interested in trying out the service itself, it would take you directly to the BIMIT plan product. You'll find that it's as simple as kind of clicking here. It's going to redirect you to an upload page. In this case, you would be able to upload an E57 or an XYZ file, registered point cloud. Sounds like as of today, we've actually upped the limit from 20 to 30 gigabytes. As Preston mentioned, it's free for now until, of course, we start to kind of understand the process itself. A few things to state that are obvious. Very, very important qualifiers. Number one, as excited as we are as fellow architects and engineers here in the call, do not depend on this for construction and design quite yet. We'd like to get to a place where the level of reliability and accuracy consistently achieves a level of kind of 99.9%. We're not there yet. Very much kind of GPT-1, as Preston's alluded to this. The use cases that I think are most relevant, I think, at this stage are getting a point cloud, uploading it, and getting a basic floor plan for general kind of space planning layout purposes. As we continue to fine tune, tweak accuracy, recall, speed, of course, I think that the level of use cases are going to continue to increase. But really, really important note. Also, for those wondering, data security, it's an important topic. All of our data right now is hosted in US-based servers, AWS, US Virginia, for those wondering. No data is effectively trained anywhere outside of the country right now. As we get more global demand in Europe and other places, that likely will need to expand. At the moment, high security spaces, we don't recommend you submit those. So please, no government buildings, nothing. Unfortunately, we're not there yet. We do have an incredible BIMIT verified service that Debbie and the team are leading. Essentially, that can kind of handle some of the more sensitive cases. Of course, the irony here is that a fully automated service actually will be more secure in the long term. For now, we'll let you know when that's ready. SOC 2 compliant for the delivery. So for all files, CAD, BIM, we're going to deliver it in a SOC 2 compliant platform. So yeah, just as you're thinking about how to use the BIM plan service, for now, see this is very much kind of in the early days of testing. We are anonymizing a lot of the data hosted in the US. It's effectively only used for training purposes to improve the service. We're not selling data, nor do we intend to in any future. And that's kind of written within our bylaws here. So super important disclaimers. With that said, guys, in the last 2 minutes, folks need to jump back to work to the two important stuff here. In the last 2 minutes, if I'm an engineer listening to this, I'm like, this is all cool, but like, when am I getting MEP? Thomas, what needs to be true here in order for us to get to the holy grail of walk into a space, scan it, press a button, and get fully precise ASBOs, including MEP? What needs to be true?
I think we shipped it with this latest release, didn't we? I thought we did. I'll say that MEP is a world in and of itself, and to say that you've completely modeled MEP only leads to more questions. It's just like, what exactly was included in the scope, and at what level of detail, and according to whose specifications, and like modeling piping is one thing, modeling piping and ducting is another, but to model every piece of equipment at LOD 400 is, I mean, I don't know, years away. So I would say that this year is when we'll probably ship things like piping and ducting. We already have kind of internal prototypes that are starting to recognize these types of elements. I don't know whether I could muster the courage to do equipment recognition at any meaningful level of detail other than just saying generic piece of equipment here, which, you know, is something that we can definitely achieve in the short term. But getting more detailed than that will require just like a total massive scaling of our training data to include all of these different categories. And it's just not something we have access to today. But if anyone listening has access to massive MEP training data, reach out to us, and maybe that could lead to an interesting opportunity for sure.
Yo, you heard it here. Guys, for those listening, we're deeply appreciative of your time. We're biased, of course, but we'd love to support you guys. For those interested in reaching out to us, you could reach out to any one of us, anyone on the team. More than happy to sit down with you to review LOD, specifications, criteria. For those working on one project or 1,000, as we've heard recently, happy to sit down with you guys and kind of work this out. So incredibly grateful. Happy Wednesday for those listening in. We'll pop the link one final time here. It's on our main website /scan to plan. Encourage you to use it. So for those, really thank you for your time, and yeah, we'll hopefully see everybody soon.
Thanks, everyone.
Cheers.
Thank you.
Sure.
Bye.